Okay, so there's one thing that we did not get through in chapter 8, and I wanted to spend a little bit of time talking about it here this afternoon. And we left off talking about what are the costs of inflation, right? And one thing we did not talk about is the way that unexpected inflation redistributes wealth. It creates winners and losers. Right? It creates winners and losers. How are we to understand why this is the case? Well, to understand this, we have to take a little bit of a side trip and talk about interest rates. And this is actually going to be a conversation that we pick up with tomorrow in chapter 10, right? So the material that we cover tomorrow in class will be on savings and investment and financial systems. And we're going to talk a lot about interest rates tomorrow, but there's I think some basic ideas that we need to understand about interest rates that not only will help us tomorrow in our discussion, but also help us understand why inflation is so costly. So let's talk about interest rates here. We all know what an interest rate is, right? It's basically the price you pay for borrowing money, right? To borrow money, to get money today instead of tomorrow, you need to pay a price for that. And that's what an interest rate is. So if you go to a bank and let's say you want to buy a car and you need to borrow money to buy a car, what they quote you is really a nominal interest rate, right? It's what economists would call a nominal interest rate. We can call that little I. What is that nominal interest rate? What determines that nominal interest rate? Well, you can really think about that nominal interest rate as having two different components. One is expected inflation. The first is expected inflation. Would anybody in their right mind ever lend you money at less than the expected inflation rate? No. At the very least, they need to be able to get the expected inflation rate back, right? Because that expected inflation rate is essentially eating away at the value of money over time. So, for instance, if you gave me $10 today and I gave you $10 20 years from now, that's a bad deal for you because that $20 10 years from now is going to be worth a lot less in terms of purchasing power. So at the very least, you're going to need to be compensated for what you think inflation is going to be. But do we know what inflation is going to be in the future? We don't know for sure. So it's the expected inflation rate. Okay? However, if somebody lends you money, do they just want to lend you money at the expected inflation rate? No, they also need to be compensated for, they need to have a real profit, right? They're going to need some profit over and above the inflation rate. And that's what we call, oops, I'm sorry, I have these backwards here. Let me do a better job with my notes. So to be compensated over and above the inflation rate, that's what we call the real interest rate. Right? It's the nominal interest rate adjusted for inflation. But this real interest rate is really an ex ante real interest rate. What do we mean by ex ante? Ex ante is just some fancy Latin terminology for before the fact. Before the fact. In other words, this is the expected real interest rate. It's the expected real interest rate. It's what you think you're going to get. But do you know for sure you're going to get that real interest rate? No, you don't know for sure because you don't know for sure whether you're going to be right about what inflation is going to be. So when people lend each other money, they are taking a risk. And of course, one of the risks is that that person won't pay you back. But another risk is that inflation could change. And inflation could eat away at some of the real purchasing power of the money that you get back in the future. In other words, unexpected inflation could impact your ex post return, meaning after the fact, or your actual return. The ex post real interest rate is just the nominal interest rate minus actual inflation. It's the nominal interest rate minus actual inflation. But this is, of course, after the fact. We only know what actual inflation is after time has passed, right? We're not going to know that before. So when I get into a loan to like buy a car at a bank, I'm doing that before I start paying the money back, right? The bank is taking a risk. And one of those risks is an inflation risk, that inflation could be different than what you think was going to happen. If it's different, it could begin to change their actual return. Okay, so this is a tricky concept because it's really asking us to think about things in 3 dimensions here, thinking about things over time. Right?
Is that symbol pi, or is that just another
Pi here is just referring to inflation, right? So this is the nominal interest rate minus actual inflation. That's what the ex post real interest rate is. It's the nominal interest rate minus actual inflation.
So does this lowercase I, stand for nominal interest rate in each?
Nominal interest rate, right? The nominal interest rate. Okay, so let's, probably the easiest way to understand how this works is to actually work through an example here. And I'm going to pick an example from history. So my parents in 1970 bought a house. And what they did is they locked into a 30-year mortgage. Okay? So in 1970, they bought a house. And they bought a house at an interest rate, a 30-year mortgage. And a mortgage has a fixed interest rate on it. What did my parents pay on that mortgage? 4% a year for 30 years. 4% a year for 30 years. Now, what was the bank thinking when they lent my parents that money for 30 years? They were probably thinking, well, I think inflation's going to be about 2% because in 1970 inflation was about 2%. And so they were thinking, well, mortgages are relatively safe. So my ex ante real interest rate will be about 2%. In other words, my real return that I can expect to get should be about 2%. Okay, that's roughly probably what the bank was thinking. So I need to charge 2% to cover what I think inflation is going to be. And then I need to get 2% over and above that to have a real profit. Okay, that's what the bank was thinking. But remember here, this is all before the fact. Ex ante. This is what they were thinking when they signed that contract in 1970. Okay, now let's move forward in time. All the way up to 10 years later. My parents still have that 30-year mortgage. However, now, what had actual inflation become? %13%. Right? Inflation had reached 13% in 1980. What does that mean about the actual return that the bank was getting on lending my parents money? What was their actual return? Their actual return was negative 9%. In other words, their ex post real interest rate was negative 9%. The bank lost a ton of money on this loan, right? In real terms, they got decimated. And that, of course, is the theme of this example. Unexpected inflation hurts lenders and it hurts savers. But who does it help? It helps borrowers. This was actually a huge windfall for people like my parents, because they essentially, in real terms, ended up spending a lot more, or I'm sorry, a lot less than they would have had to. However, did my parents really benefit from this? And I would argue it's not so clear. And the reason is, what happens when something hurts lenders? Anybody familiar with the history of the financial system in the US in the 1980s? What ended up happening to the US financial system in the 1980s?
Don't they shut down? Like
Exactly.
these banks and stuff shut down?
Exactly. You can have bank failures, right? You can have bank failures. And the result of this is that there were a lot of bank failures. Banks lost so much money that they essentially went out of business. There was a big government bailout of many of these banks because of federal deposit insurance, the FDIC. Many of these banks had insured deposits in which the government was insuring. And so who ultimately paid for a lot of this was taxpayers. You're right, Sonny, there was a lot of stuff also going on in the 1980s, like bank deregulation, et cetera. But the biggest problem for banks in the 1980s was that unexpected inflation hurts lenders and it helps borrowers. But that's not really so great for the economy overall, right? There is no better way to ruin a financial system than having unexpected inflation. It creates havoc because it creates a lot of winners and losers. And of course, what happens to those losers is that they're less likely to engage in the same kind of activities that got them in trouble in the first place. So as Zach said, a lot of banks went out of business in the 1980s. And as a result, a lot of people found it very difficult to get loans to buy a house because banks, even the banks that survived, were much less likely to make loans, having been burnt by the high inflation of the 1970s. So I would argue that while this creates winners and losers, it wasn't very good for anybody, right? There's no better way to ruin a financial system than having unexpected inflation. So, just to think of about a more extreme example, Argentina, right? Argentina is one of those countries that when you want an example of how not to conduct yourself, look to Argentina, because Argentina is an economic mess. So think about how inflation has hurt savers in Argentina. If you put $1 million US, okay, if you took $1 million US in 1960 and you converted it to Argentinian pesos and you put it in a bank in Argentina in 1960, okay? So you took $1 million US, a lot of money, you converted it into Argentinian pesos and you put it in an Argentinian bank. If you left it there since 1960, how much would that money be worth today? How much would a $1 million be worth today? Drum roll, please. Essentially zero. How? All of the value got eaten away by inflation. When you have 100%, 200%, 300% inflation over that long of time, the value of your money gets completely eaten away. And so instead of creating wealth, like if in the US, if you would have put $1 million in the bank, you'd have a lot more than $1 million today because you'd be creating wealth. But saving in the Argentinian financial system because of all the inflation is essentially a way to destroy wealth. And so this is what I mean when I say that this is one of the costs of inflation. Tomorrow, we're going to talk about how financial systems work. And one of the things we're going to talk about is that financial systems are really important. They are very important to economic growth and economic progress. But one of the ways, the surest way to ruin a financial system is to have unexpected inflation, because inflation kills savers and it kills lenders. And when they get killed, they stop lending. And that's not good for anybody, right? That's really not good for anybody. And so we will build on this more. But really, I guess the main takeaway that I'd like to give you is what is best for economic growth? When we think about inflation, what is best for economic growth? The most important thing is steady inflation. That is the most important thing. Inflation can be 2%, 3%, 4%. The level probably doesn't matter nearly as much as the fact that it's steady. Lesser importance is having low inflation. Probably having low inflation is better than having high inflation, but having steady inflation is the most important thing, right? That's the most important thing. And so we're going to come back to this much more tomorrow when we talk about financial systems. But, and we'll talk about how one of the things you observe among poor countries is they have weak financial systems. And in general, one of the things that creates very weak financial systems is having volatile inflation, right? Inflation that goes up and down and is unpredictable, because that's the kind of environment that nobody wants to lend money in, right? And if you can't borrow money, that's going to be a big impediment to growth. Okay, so that is, voila, the end of chapter 8, right? The end of chapter 8. I am going to give you a couple of questions to work through at the end of chapter 8. Of course, chapter 8 is not going to be on our quiz today, but it will be on your first exam next week. So let me give you a couple of end of chapter questions that you can work on if you feel like you need to work a little bit more on calculating unemployment or some of the other things we talked about. These would be some good questions to review if you have a little bit of time this weekend, right? Questions 3, 5, 8, 10, and 11. The other ones are okay too. These are the ones that I kind of jumped out to me as being the most valuable. Okay, all right. Anybody have any questions about this? All right, let's quickly moving on to something else. I want to do that CPI example, and then I'll ask you all if you have a couple of questions before the quiz. So here's the CPI example that I gave you yesterday afternoon. How does this question, or how does this example look different from the GDP deflator or the aggregate price index question that I gave you? How does a CPI problem look different?
Is it because all the quantity is the same?
Exactly, Gabe. You got it. Remember, one of the big differences between the consumer price index and the aggregate price index is the aggregate is the quantity changes over time, but in the consumer price index, the quantity is the same year to year, right? That's one of the big differences. So let's calculate the consumer price index for 2010, 2011, and 2012. And in the interest of time, because we're running a little bit late and I want to make sure we have lots of time for the quiz, I'm not going to throw you in the breakout rooms. Let's just work through this together. What's the indexing in 2010? Remember, 2010 is the base year. We're using 2010 as our base year. So what's the consumer price index going to be in 2010?
100.
100, right? Because the index is always 100 in the base year, right? That's the easiest one to compute, right? That's the easiest one to compute. All right, what's the consumer price index for 2011? Remember, we want to calculate the price of this bundle in the current year and then divide by the price of this bundle in the base year. And then we want to multiply that by 100. Brenna, did you have a chance to work this problem? What did you get for the consumer price index in 2011?
For 2011, for just the CPI, I got 130.8. No, 531.25.
Anybody else get that?
I got that.
Yeah, I think I'm like ahead of.
The 531 was the price of the basket. You were right with the CPI, I think, though.
Right. So let's do this here. What the numerator is the price of the basket in 2011 times the quantity, right? So this should be 1.5 times 100 plus 2 times 150 plus 325 times 25, right? That's the price, that's 2011 prices times the basket. And then the denominator is 2010 prices, the base year prices times the denominator. So 1 times 100 plus $1.50 times 150 plus 3 times 25 multiplied by 100. I actually got 132.8 when I did this. Did anybody else get that number? Let me break out my calculator here.
I think you have a 3.2. Your last number on the numerator seems a little off, but I don't know what your hand.
Yeah, it's 3.25 times 25.
It says. Yeah, shouldn't that be 2 times 25? Or 3 times 25?
So it's the price in the current year divided by the price in the base year.
Sorry, I had my number written down.
Yeah. So I think if you do your math right, you should get 132.8. Setting aside our problems with using our calculators, do we understand where these numbers are coming from, right? The numerator is the price in the current year times the quantity, and then the denominator is the price in the base year times the quantity, right? You should get 132.8. I'm pretty sure of that number.
I got that. If you don't use like the correct parentheses, then you're gonna get the other answer that everybody else is getting.
How about 2012? Well, now we want to use 2012 prices times quantity in the denominator. So this would be $1.75 times 100 plus 2 times 150 plus 3 times 25. That's the price in 2012 times the bundle, divided by the price in the base year, which is really what you just did this when you calculated 2011. What did anybody want to share their answer for 2012? Faith says 137.5. That's what I got too. 137.5. So once you have the consumer price index for each of these years, now we can go and calculate inflation. Let's calculate what inflation is between 2010 and 2011, and then let's also calculate what inflation is between 2011 and 2012. Okay? So what's inflation between 2011 and 2010? We want to take the percent change between these two numbers. The percent change between these two numbers. So we want to get the new observation minus the old divided by the old multiplied by 100. And you should get an inflation rate of 32.8%.
I'm sorry. I don't know if I'm doing this math like incorrect or not, but I got 135 for the CPI for that. I
I
don't
got
know why.
135 too, but
Like-
I think I know why I got 135. So the number I have written down for the 2010 Z is 3.25 and not 3. So my number was a little skewed from your number. I don't know
Mhm.
if I copied it down wrong or something, but
That's what I did as well.
Okay.
Yeah, no, I think you had it written differently yesterday.
Did I really? Ah, shoot. Well, as I said, it's small differences in math errors. That's a small mistake. If it was a math error, maybe I did copy it down wrong. I didn't think I did, but the key is to understand conceptually what we're doing, right? So yeah, if you got 135, that's close enough that you probably either I copied it down wrong or you made a small math error. Okay. So to get the inflation rate, everybody though sees conceptually what we want to be doing, right? Taking the percent change in the consumer price index between 2010 and 2011 to get inflation between 2010 and 2011. How about between 2011 and 2012? Let's use my numbers here. I want to take the consumer price index in 2012 minus the consumer price index in 2011 divided by the consumer price index in 2011 and multiply that by 100. And you should get 3.5%. As I talked about a minute ago, this calculating inflation with the consumer price index is very similar to calculating that aggregate price index. Really, the only difference is that the average price index, the quantities change year from year because it's using GDP statistics. Where in the consumer price index, the quantities don't change year for year because it's using that estimated bundle. Okay? But in practice, these questions are very, very similar. And so if you understand that fundamental difference, you should be pretty well prepared to answer either of these, right? To answer either of these. Okay, who has a question about any of this? Does that make sense? How about anything else about the quiz before we take it? Any other questions about Chapter 7 in GDP, or any questions about comparative advantage from the other day? Sunny asks, is there an easier way to calculate GDP per capita? No, not really. I mean, you to get GDP per capita, you take GDP and you divide it by the total population, right? And so, as I said, in the U.S., that number is roughly about $60,000. I don't know what it is exactly, but roughly about $60,000 per person. So, yeah. To give that some comparison, in China, that number is more about $17,000 per person, which shows you, once again, some of the vast differences in GDP across countries, even when you consider differences in population. But no, these are big numbers. So you have to, when you talk about GDP, you're going to have to talk about things in billions and trillions of dollars. Right, that's just the way it works. All right, well, I sense a sense of flagging energy here. Maybe it's me projecting onto you. But I do get the sense that maybe we should just take the quiz, right? Okay, so unless, speak up now or forever hold your peace, but if not, I'm going to send you the quiz. So please, on the quiz, put your name on it. I should have your email on it, but just as a backup, please put your name on it. There's a name part at the top of the quiz. So just to make sure that I can link up the quiz per person. At the end of the quiz, there's a button that says, I'm forgetting exactly what it says, but it says to send, it will send you a copy of your quiz. And so when you get to the end of the quiz, click that button, send yourself a copy of the quiz so that you have a record of the quiz, right? That you can either study with, or if God forbid something on my end happens, because like I said, I was having a couple of funky issues, then we will both have a record of what you submitted on your quiz, okay? Also, there's a couple of parts where you can take a picture and upload to your quiz. If that becomes a problem, just send me your pictures on email. Okay, just send me your pictures on email. Let me know. I will be turning my video off and I will be muting, but you can text me or chat me if you have any questions, all right?
Is there a time limit?
There is. It's going to be a half an hour, so I'll give you to
Same thing,
1:45.
okay.
I'll give you a little bit extra time, right, till 1:45. So that should be plenty of time, all right? Okay, so give me a couple of minutes because I have to put your emails in. So it would just take me a couple of minutes, but you should be getting an email here in a moment, all right?
Couldn't you just send the link in the Zoom chat?
I'm sorry, what'd you say, Faith?
Like, couldn't you just send the link in the chat on Zoom?
I don't know. I haven't tried that. I think it's better with email because this is a closed email through Google, so it's only using your Cornell College ID. Let's just do the email. I don't want to experiment, right? Thanks. So okay. So hold on, everybody. It should come to you in a minute. All right. And chat me if you have any questions. Yeah, hold on. Yeah.
Oh, sorry, you're busy. I just wanted to know if you wanted some fresh squeezed lemonade. I made this morning. Really good. We just had good stuff. If you like it, I'll leave it on the counter. Yeah, or I've come out and go back. Sorry about it.